This is Mrs. Naslund, and today we'll be talking about transformations and congruency. So we're going to look at some of those transformations that we talked about yesterday, and then also talk about figures that are congruent. Congruent, the definition of congruent, is figures that are the same size and shape. Okay, so they can be in any direction as long as they are the same size and same shape, they are congruent. So let's take a look at these two figures here, figure A and B. These are the same size and same shape, so these are congruent. In figure C and D, one is turned, but they're still the same size and same shape. If I turn C back up here, it would fit perfectly on D, so these are congruent. Now E and F, these are not congruent. Okay, if we look at them closely, you'll see that E is much bigger than F, so they are not the same size, so these two are not congruent. In G and H, these aren't the same shape. It looks similar, but this has 5 sides and this one has 6, so these are not congruent as well. So if we take a look at these ones to decide are they congruent or not, this shape, this diamond, is the same shape as this one. If I rotated these, I would be able to see that they're exactly the same shape. They're congruent. And if I rotated it even further, I would be able to see that this one is congruent as well. Now, the other two shapes are not congruent because they're not the same size, and in this case, it's not even the same shape. Now, if we look down here and try to decide which ones are congruent, I can see that there are 3 congruent triangles as well. There's a congruent triangle right here that takes up 3 of the boxes here, and here I have 2 plus these half, which make it congruent as well. And then here I still see that it takes up 3, so this one is congruent as well. This one only takes up about 2, and this one takes up more than 3, so I know that those two shapes are not congruent. Now we're going to apply what we just talked about with congruency to our transformations. So our transformations we talked about yesterday was rotation, remember, which is a turn of a shape, reflection, which remember is a flip over a line, and translation is when we slide our figure across the line. So the question is, will the reflection of the figure across the line produce a congruent? Remember, congruent is an object that's the same shape and same size. Will it still be congruent to each other? So let's go ahead and try it. If we reflect this object over the line, so I'm going to go ahead and reflect this object over the line, 2, 3, 2, 3, goes down 3, my lines are not the straightest, but you can see, goes over 2, and we connect them. Okay, it's a reflection over the line. Are they congruent? Are they the same size and same shape? Yes, they are. Okay, yes, they are. So just because I reflect something, it still stays congruent with the shape. So we've already tried reflection. Let's try rotation. In this case, it wants me to rotate it 90 degrees clockwise. So I know the clock goes this direction, so I'm going to turn it this direction. And I'm going to start with this one here. Goes over 3. 1, 2, 3. And then when I rotate it this direction, I'm going to go down 2, 1, 2, and then I'm going to go ahead and connect those two. So I've reflected my shape. Is it the same size and same shape? If I drew my line straight, you would see that yes, it is still congruent even when I rotate the object. And lastly, with translation, remember the slide across the line. If I translate the object, you will see that the object is still congruent or the same. It's still the same shape and same size. So our transformations of reflection, translation, and rotation do not affect whether the shape is congruent or not.